Alright guys, we're going to go ahead and start our rolling a penny lab. So you should have your directions in front of you. First thing you need to do is record the date, the thickness in millimeters using calipers. Okay, and that's going to go down here, that information. Okay, and then we're going to use this graph paper to calculate the area for it. So you're going to place your penny on the graph paper, count the number of full squares, number of partial squares, and then calculate the area. Okay, so that's step 2. Alright, and I'm going to show you how that's done on the smart board, on the smart notebook. So, what you're going to do is put your penny on the graph paper, grab a pen. We're going to go ahead and use red. Okay, this is what it should look like beforehand, right? Okay, trace it around. Also, obviously, much better tracing job than Miss Woods is doing using the mouse pad on. Okay, not so bad, but I'm going to go ahead, take your penny off. There are your squares. Okay, let's go ahead and count them up. So, how many full squares do we have? Well, let's not count any of these because none of them are actually technically full. Neither is that one, so we'll count this one. 1, 2, 3, 4, 5. You guys should have done something like this in math class at some point in your school careers. Okay, you're going to count all the full ones. Okay, and let's go ahead and let's say this is, let's say 100. Okay, now you count the half ones. They don't technically have to be half. This one is almost about half, but these guys are pretty full. Now that's going to be combated by these that are pretty small. And basically the idea is if you count partial ones throughout the whole time, let's say that there are 40 of them, okay, so far, okay, there's 40. If you divide that number by 2, you end up with 20, another additional 20 squares if we count all the partials, alright, and then we'll go ahead and say that 100 plus 20 is 120 squares altogether. A plus B, 100 plus 20. Okay. So that's your first step. Okay. That should have you fill out this top portion. Then you're going to go ahead and roll the penny. Here's some important things. They're highlighted for a reason. Adjust the rollers for the rolling mill so the penny just fits in snugly. Okay. Roll penny. Don't do it too much because you can break the rolling mill. We want to keep our rolling mill safe. So please follow the directions. Okay. After adjusting the rollers, you're going to put it through. Okay. Then you're going to crank the rolling mill, let it out, and you're actually going to do this twice before adjusting the rollers. It says it up down here. But before you do that, when you adjust the roller, you're only going to do it no more than 1/8 of a turn. So you flip it from horizontal to, like, you just twist a quarter of the way around, okay? No more than that. Again, it can hurt the rolling mills, okay? You're also going to want to turn your penny 180 degrees. If you put it through one time, you'll start to see an oval form. Turn it so that you try and get as much of a circle going as you can. It'll make your data a lot easier to calculate that way, okay? Again, don't tighten it with too much excessive force. It can cause the rolling mill to break. You always want to put the penny twice through the rolling mills, okay? Stop the rolling before the penny goes off the graph paper, okay? Step 5, it says record observations and impressions, just like you did in step 2. So I'm going to go back to our pad, okay, and find our new penny. Rolled penny. Oop, wrong thing. There we go. Here's your rolled penny. Okay, this one's obviously much prettier than the ones you will make, but yours are going to be pretty awesome too. Okay, so we're going to trace our penny. Again, notice that oval shape. If you turn your penny, you'll get a much nicer time. Okay, go ahead and move the rolled penny off to the side, and we're going to count our full squares again for after the penny. So how many full squares do we have? We've got 1, 2, 3, 4, 5, 6, 7, so on and so forth. This is not going to be fun for you. Let's go ahead and say that there are 170 squares now. Alright, then we'll go ahead and do our half squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Let's go ahead and say that there are 70 half squares, so that will give us 35 additional squares to our 170. So again, we're going to do the whole total squares, a plus b. 170 plus 35 is going to be 215. Okay, so we should be pretty well on our way to finishing up the lab then. Okay, you're going to just do your observations and you're going to calculate some information. So we're back down here. There's the rolled penny graph, counting our squares, additional observations and impressions. There's a couple of questions for you to answer. Name the term for the mechanical property the lab illustrates. You should know this. It's malleability. Explain, just like in the notes, why pennies are malleable, what the property, what allows metals to have that property. Okay, any other information? But then here we go to the math interpretation questions, which sometimes trips people up. So how do you do the math interpretation questions? So the penny at the start was how many times as thick as a penny after it was being rolled? Show your work. In other words, guys, how much did you diminish it? So I'm going to go ahead back here, and we'll go on to the next one. What you're going to do is you're going to decide the thickness of the penny before from the thickness of the penny after. So before, let's say it was 1.43 millimeters thick using those calipers. Okay, we're going to divide that by the total thickness after you rolled it, which using our calipers, we need these because look at this, they can be as low as 0.88 millimeters. You're going to divide one by the other, right, the before by the after, 1.43 by 0.88, and you'll get something about 18 times 17.8, okay, 7, like that, 17 times as thick at the beginning of the lab than after you rolled it. So what happened to all that thickness? Okay, well, let's take a look at the area. Okay, you're going to do the same thing, only this time it's going to be the after being rolled divided by the before. Okay, so if you look at your information that we just calculated earlier, my examples were that we had 215 squares, right, after we rolled it compared to our 120 squares. All that information is right here. 120, 215. Okay. After that, and what did you do to the area? And you should end up with like 10, we'll keep that color anyways, 10.75 times as large. So your answer would go right there. Okay. So the thickness decreased, but the area increased. And that's where we're going to go compare right here. So it says calculate the volume of the penny at the start and after it is rolled. Compare the two volumes, show your work. So before rolling, you had let me go back here. Before rolling, you had 120 squares. Right? And remember that volume is area times height, right? And your height, in this case your thickness, was 1.43. So what's your area? Or what's your volume? Sorry. 120 times 1.43 equals 291.6 squares per millimeter. That's your new volume. Okay? Now you're going to do the same thing after rolling. Okay? You do your 215 times 0.08. Now, these numbers were made up, so what we are going to do, you're going to use your own information. You should find the volumes are the same, okay? Or at least relatively close. Because what's happening is, as you decrease the thickness, you're increasing the area, okay? You're not adding any more mass to that, and the density does not change, so your volume should not change. All right, guys, good luck, and we'll see what you have after we're done.